we need to determine if a relation is a function or not. A lot of times in math, we need to know if a relation is a function or if it isn't, because functions act in a special way that relations don't always do. So let's review real quick. What is a function? A function is a very special type of mathematical relation where each input, or our x values, goes to exactly one output, and our output are our y values. Each input goes to exactly one output. And all functions are relations, but not all relations are functions. If we were to draw a Venn diagram of what that would look like, here we have the world of relations. So there's lots of math rules where there is a relation between the x value and the y value. There is a correlation or relationship between the input and the output. Within that family is a special family of functions. So all functions are relations, but not all relations are functions. And we need to know what relations are functions because functions act in a specific way. And then here is something to remember. What does it mean when each input goes to exactly one output? Well, if we go back to our wonderful little function rules way back in elementary school, that means that when I plop in an input, I'm only going to get one output as a result. So whatever rule this is, I can only get one answer as a result of an input. So this would be an example of a function. Here would be an example of something that's not a function. I have some sort of mathematical rule and I plop in an input and I get two or more answers as an output. So if I plop in an input and I get two or more answers as an output, that is not a function because the input is not going to exactly one output, it's going to more than that. So, and a function, each input has exactly one output. Not a function, each input will have more than one output. So, why in the world do we even care if a relation is a function? Well, functions, they are just very special rules, and they're very reliable. They all act in certain ways. And there are families or groups of functions that they all look similar and they behave in similar ways. And so if you can say, oh, this is a function, it's part of this family, I know it's going to do this, this, and this, and this. So we can use that knowledge to use the functions and predict things. So let's go ahead and practice this idea of one input going to one output, or an input having exactly one output. And what does that look like? And can we determine if a relation is a function or not? So we'll start with some discrete relations, and that's just meaning they're individual points, they're not connected. And you'll see them kind of in four different examples. So you might get a relation that's listed as ordered pairs. Okay, so if we have a relation that's listed as ordered pairs, how can we tell if that relation is a function or if it isn't? Well, if the same x-coordinate occurs in more than one point and the y-coordinates are different, then it's not a function. Okay, so that means, going back to our rule, if I have one x value and I plop it in and I get more than one y value, it's not a function. So let's take a look at this. 3, I plop in a 3 and I get out a 4. Do I see any other 3s? No. Okay, so that one's fine. I plop in a 5 and out comes a -2. Oh, but I notice in this one, I also plop in a 5 and I get an 8. So this is an example where I plopped in an input, in this case 5, and out came a -2 and an 8. That is not a function because of this. So not a function. Okay, the input of 5 where the x value of 5 goes to more than one output. One y value, one output. Let's take a look in this example. Do I have my x values, do they go to more than one y value? Let's see, 0 goes to 8. I don't have any other 0. Next I have an 8. 8 is going to 0. I don't have another 8. Next I have a 2. I don't have another 2. And I have a negative 3. I don't have a negative 3. So this is an example of a function. And why? Because each x value goes to exactly one y value. So that's how you can tell if they're a function based, if they're an ordered pair. Let's go ahead and see if they're a table. This is kind of the exact same thing, just instead of listing them as ordered pairs, you're listing them in table value. So if the same x value occurs more than once with a different y value, then it's not a function. So I'm going to take a look at my x values and just see if any of my x values are repeated. So 2, 3, 7, 9, 10, none of them are repeated. This is a function because each x value goes to exactly one y value. Now, one thing that might be a little bit new is this concept of mapping. And this is just a way of showing what x value matches or goes to what y value. And so how can we tell if this is an example of a function or not? Well, if more than one arrow comes out of an x value, then the relation is not a function, because that's saying I popped in an input and I got more than one output. So here's an input, it's going to one output. Here's an input, it's going to one output. Uh-oh. Here's an input, and it's going to two outputs. So that's an example where it looks like this. I plopped in a 2, and out came a 5, a 1 and a 9. So that is not a function. The input of 2 is going to more than one output. All right, and let's cover what a graph would look like. And again, this is a discrete graph, so none of these points are connected. They're all just individual little points. And if this is a function, or if it's not a function, if a point is directly over, meaning up and down, another point, then the relation is not a function. And I can see right here, I have 2 points that share the same x value. This is the point, let's see, 1, 2, 3. This is -3, 0. And this is -3, 1, 2, 3, 4, -4. So here's a case where I have -3, and it's sharing 0 and -4. So I popped in a -3, and I'm getting 0 and -4 as a result, as an output. So this example is not a function. And that's because the -3 input is being shared among 2 outputs. Let's talk about how do you determine if a continuous function or a continuous relation is a function or not. And I'll say that these are pretty easy. There's a nice trick for knowing this. And remember, continuous just means all of the points are connected in a nice smooth line. So a continuous graph, if the graph wraps over above itself, then the relation is not a function. Like if you can map it like this. And something called the vertical line test. We love our vertical line test. Sometimes you'll hear it referred to as the VLT, because we like to abbreviate things too. And this works for both continuous and discrete graphs. We can use the vertical line test to determine whether or not a relation is a function. It states that if you can draw a vertical means up and down, if you can draw a vertical line that passes through your graph, your line of your equation, or whatever that relation is, more than once, then it is not a function. So an example here with this heart, I can draw a vertical line a lot of places in this graph. Like here would be an example. And my vertical line touches my graph in 2 points. If it can touch the graph in 2 points, it's not a function. So I could do a vertical graph here, a vertical line test. I could do a vertical line test here. It touches the graph in 2 points. That is not a function because, again, like let's take this one. Here I have an x value of, what is that, 1, 2, -3. And my x value is being matched with 2 y values. So it's looking like this. I'm popping in a -3 and I'm getting 2 values as a result. So that is not a function. With this case over here, can I draw a vertical line anywhere through my graph and have it touch the graph only in 1 point? Or I guess 0, but so I could draw a line here, it's only touching it at 1 point. I could draw a line here, it's touching it at 1 point. I could draw a line here, it's touching it at 1 point. And these lines are continuing on forever, but no matter where I would draw that line, I'm only going to touch the graph in 1 point. So this is a function. This is an example of a function because no matter what my x value is, I'm only going to get 1 y value as a result. Here's an x value, I only have 1 y value. So that is an example of a function, and my heart is not a function. Vertical line test is a super easy test, but remember why the vertical line test works, and it's just because when you pop in an input, you're getting 2 or more outputs as a result. So that is how to determine if a relation is a function or not.